Hello and welcome back to this, another Duncan Codes. We've been following the University of Helsinki's massive open online course. We're on part 4 at the moment, which is the Introduction to Object-Oriented Programming. We've got quite a way through, probably about halfway through. What we're going to do today is see how much further we can get through and get some more challenges complete. So here we've got our first quiz. So we've got examine the following programming code. We've got public class counter, private int value. Got our constructor here, public void change value takes a variable of modifier this dot value minus the modifier public return that. So counter equals new counter 7. Then we've got change value, so we're calling our counter. We've got change value, which is this one here. System out print get value. So if our initial value is 7, which is being stored in this value, then we're calling the change value. And they're saying that this value is minus the modifier amount, so that should be 7 minus 5, so hopefully that should be 2. Excellent, off to a good start. Create a class called song. The song has instance variable name, string, and length in seconds integer. Both are set in public song string name int length constructor. Also add to the object the methods public string name, which returns the name of the song, and public int length, which returns the length of the song. The class should work as follows, and we've got a little example there. So let's head across to TMC Beans and get the challenge open. So we can close this one, det. And then let's have a look at this song one, just here. So we've got some code in here already. What I'm going to do is just dock this. So I press Control 1 on my keyboard to get that up, and then press the 2 squares next to each other, or the 2 windows, and that will dock it for us. Now let's just move that to the side and move this over, and then we can work on these side by side. Okay, so the first thing we need to do is create the class called song. So we'll right click on our default package, click new, Java class, and it's called song, like so. So now we need instant variables, which is a string. So we've got private string name, and then we've got length in seconds, so private int length. Then we have our constructor, public song, and then we have string name, then int length. Open and close our curly braces there. Also add the objects to the method public string name and public int length. So let's just quickly pop those in. So if we type P and U and press tab, we get public string and then name. Oh. And then we need public int length. So we're going to need to put some returns in here. So just for now, I'm going to return 0. And then here, I'm just going to return that. There we go. Right, let's have a look at our constructor and what we need to actually put in here. So the constructor, what we can do is head to our main, and if we have a look at this code here, you can see that when we're creating the new song, we're passing 2 bits of data, so the song name and presumably the length in seconds there. So what we're going to need in here are to set the parameter to the instance variable. So we'll do this dot name is equal to name, and then this dot length is equal to length, and it looks like I've got a typo here. There we go. So when we call the name method, it needs to return the name of the song. So we can say return name, like so, and then this last one we're going to update that to return length. Okay, so that should be everything covered. So if we head back to our main and uncomment this code, hopefully we shouldn't have any errors. Let's give it a run locally and see what we get back. Off to a good start. That's all passed and done and dusted. There we go. So let's give this a little refresh, scroll down. Program exercise film. Create a film class with the instance variables name and age rating. Write the constructor public film, which takes 2 variables or 2 parameters, string film name and int film age rating for the class, and also methods public string name and public int age rating. The first of these returns the film title and the second returns its rating. Okay, let's OK this and close this one down. Oh, do you know what we haven't done? We need to do our GitHub, don't we? So I'm going to right click on the project here, head to properties, get the source of the project, which is here, copy that, let's open, and then I'm going to do a CD for change directory because I'm in the wrong folder at the moment. And then I'm going to get rid of the last part of the project. Oh, I didn't like that, did it? Put another one of those in. There we go. And now what we're going to do is git add for the new bits that we've just done. I'm going to do a git commit. So we've just completed part 4, exercise 10. So completed part 4, exercise 10. Commit that, and then we can do a git push view origin and master, like that. Brill. Right, now let's close this one down, and then let's open this film one up here. Here we go. The first thing we need to do is create the class, create a film class. So let's right click on our package, new Java class, film, there we go, capital F. It says that we need 2 instance variables. One is public, sorry, it's not public, is it? It's private string name and private int film age rating. Bro. So we can create our constructor. Remember, there's the shortcut that we can use, which is pressing Alt and Insert on our keyboard, and we get all of these little auto-generate code bits for us. And we can use those to select any or all of the methods that we want to be used in creating the constructor. And that fills out that information for you automatically. So then we need to do public string name, and that is going to return name. So it's going to return name from this line here, line 12. And then the last thing we need is public int, and was it film age rating? Age rating, like that. And then what we're going to return here is film age rating from line 13. So film age rating, like so. So this constructor is going to create the data, or sorry, prompt us for the data to store in name and film age rating. And you remember, you can select whichever variable and it will show you any corresponding variables. So the variable or the parameter that's passed here as name is going to be saved in here, and then the parameter that's passed for the film age rating is going to be saved in here. Okay, so let's head back to our code and untest this. Untest it, uncomment it, sorry. So if we select it all and press Control and /, oh, that didn't work, did it? Oh, it's probably because it's got gaps in there. If we do this solid block, let's try that. There you go, Control and / does work, but not on blank lines by the seams of it. So let's do these. There we go. So we've got an error, which is fine, because it's just an import error. So you can type it in manually, or you can press Alt and Enter on your keyboard, and you'll get this list up here. Or you can click on the light bulb there. But we just need to add our import. That should go away, no more errors on screen. So let's give that a run locally and see what happens, see what we get. Brilliant, that's passed as well. Let's send that off. So let's give that a refresh. Oh, hasn't sent off yet. In fact, while that's doing that, let's do our git bash. So let's do git add for the new code and comment lines that we put in. Then we'll do git commit -m completed part 4 exercise 11. There we go, and then we can press up on our keyboard to get previous commands, and then we can use the git push u origin and master there like that. Let's give that a refresh. Very good. We click over here, let's close this down. Let's scroll down here. As we came to notice, methods can contain source code in the same way as other parts of our programs. Methods can have conditionals or loops, and other methods can also be called from them. Let's now write a method for the person that determines if the person is of legal age. The method returns a boolean, either true or false. So here we've got an example. If the person's age, or this.age, is less than 18, return false, otherwise return true. So this method could be written more succinctly in the following way. So return this.age greater than or equal to 18. So the return value will be of type boolean. If it's true, they'll be equal to or over 18, and if it's false, they'll be less than 18. So here we've got an example with Pekka and Antti. So we've got Pekka.growOlder. So while they're less than 30, or the number's less than 30, it will add 1. Pekka's got 1 call to the growOlder function. Is Antti of legal age? Well, no, that will return false because Antti will only be 1 year old, but Pekka will return true because they are 30 years old. Let's fine-tune the solution a bit more. In its current form, a person can only be printed in a way that includes both the name and the age. Situations exist, however, where we may only want to know the name of an object. Let's write a separate method for this use case. So here we've got a getter, so we've got public string getName, and then return this.name. The getName method returns the instance variable name to the caller. The name of this method is somewhat strange. It is the convention in Java to name a method that returns an instance variable exactly like this, i.e. getVariableName. Such methods are often returned to as getters. And then we've got an update to our class diagram, that's good. You can see here at the bottom that we've got getName, which is of type string, and it will return type string as well, which will be the name. Let's mod the main program to use the new getter method. So we've got the same program that we saw before. So depending on which of these arguments are true, it will return the name. So Antti is underage, which is this one here, and Pekka is of legal age here. Create a class gauge. The gauge has the instance variable private int value, a constructor without parameters, sets the initial value of the meter variable to 0, and also the following methods. So we've got 4 methods there. Public void increase, so remember void means that it doesn't have a return type. Grows the value instant variable by 1. It does not grow the value beyond 5. Okay, so I'll tell you what we can do then is start creating these as we go, rather than reading through it all and then me forgetting and having to type it out again anyway. So we need to create a new class, so it's going to be called gauge. So G-A-U-G-E, excellent. And then, so it says the gauge's instance variable private int. So it's only got 1 instance variable, that's fine. So private int value. Then we've got basically a default constructor, isn't it? I think it said. Oh, okay, so it's not quite default, but so it sets the value of value to 0. So public gauge. So it doesn't take any variables, but it does set the meter to 0. So constructor without parameters sets the initial value of the meter variable to 0, and also the following 4 methods. So there, I wonder if they mean another variable, because we've got public int value, but we don't have a meter variable. So we'll keep an eye out for that. So let's do this dot value equals 0. Oh, there we go. And then on the bullet points, public method void increase. So we've got public void increase. And what that's meant to do is grows the value instance variable by 1. It does not grow the value beyond 5. So what we can say is if value is less than 5, did it say less than or equal to? We'll keep an eye on that one as well. We'll test that and see what it comes back as. So if value is less than 5, value, so we can do a few different things. We can do plus equals 1, or value equals value plus 1. I'm just going to do plus. There we are. We don't need an else. What we can do though is, because we're going to get quite a few closed curly braces, we can start to add some comments if that would be beneficial. So end of if statement, end of increase method. There we go, and we just don't get quite so confused. So we've got another method which is public void decrease, thankfully not decrement or decrement, which I still can't say. go, and then decrease the value instant variable's value by 1. It does not decrease to negative values. Okay, so if value is greater than 0, hang on, that's less than, isn't it? Greater than 0, value, we can do minus minus. So we've got end of if. We have got end of decrease method. Let's see what we've got next. So the third bullet point now, we're at method public int value. So public int value, we know because it's not a void, it's an int, that we're going to return an integer. So what are we returning? Returns the variable, the value of the variable. So return value. It's a nice easy one. And then public boolean full returns true if the instance variable value has the value 5, otherwise it returns false. So we can do public boolean full, and then what we can say is return this dot value, what does it say if it's the value 5, this dot value equals 5. Okay, let's give that a test. Oh, there's no point in testing it, I haven't uncommented the code from the main class, but they passed anyway, that's good. So that obviously means that what we've written works. So let's get that submitted. Let's just have a look at this code anyway. So they're creating a new object. So that's the gauge class, that's the object they've created. So while G is not full, because remember we've got the exclamation mark, which means not full, and we've got the value, and then we've got, oh okay, so then it'll print out the full value. Okay, that's relatively straightforward. Right, let me move that to the left again. Let's give that a wee refresh. Let's get to our git bash. We'll do git add, full stop, git commit, -m, and then we completed part 4, exercise 12, and then let's do a push. Git push u origin master. There we go. Excellent. Okay, let's give that one a close. Ooh. There we go, cool. Right, let's scroll down. A string representation of an object and the toString method. The toString method's great, very, very useful, especially when working with arrays and things like that. So we are guilty of programming in somewhat a poor style by creating a method for printing the object, i.e. the print person method. The preferred way is to define a method for the object that returns a string representation of the object. The method returning the string representation is always toString in Java. Let's define this method for the person in the following example. So let's open up our NetBeans, Apache NetBeans. So this is the example that we've been following along with for quite a while now. Also, remember you guys can upload this one to your GitHub as well. This would be another good little project to keep track of. So we are in the person class, we can see that there, and this means that there's all of this sort of stuff before it. So then we've got our public string, toString method, and then what we're doing is we're returning the variables. So we've got this dot name, which is on our line 13, and this dot age, which is on our line 14. The toString functions as a print person does. However, it doesn't print anything, but instead returns string representation, which the calling method can execute for printing as needed. The method is used in a somewhat surprising way. So here we go. We've got system.out.print, and then we've got anti, and what that's saying is that it's exactly the same as printing out systemout.out.println anti.toString, like that. So let's add some more bits in. So interestingly, the .toString method is a pre-populated one, and then you can add in whichever variables you want to add in. So if we click generate, there you go, it comes up like this. We'll need to change it slightly, but if you've got a really big class, potentially it could save you quite a bit of time. So let's see, what did they do? They did this name. So actually I'm going to delete most of this and start it again. There we go. So let's return this dot name plus space, comma age. It's funny concatenation, having to think about all of the pluses, sorry, not the pluses, the spaces that you need to put in. to make sure that your code reads well, or the printouts read properly. Years, quite an awkward thing to explain to someone who doesn't code, I'm sure. So if we press Control 1 on our keyboard, it'll bring up our projects here. Let's go to person. I didn't mean that, I meant this one. And then if we do system out, and then what have I made? Derek Stan. Let's print out Stan. And then what I'll do is I'll just quickly comment these bits out. So Control and / comments out, and then let's give that a run. So we've got Stan, age 0 years, and I spelled years wrong. Brilliant. There we go. But it's a nice little method, that. And like I say, you do use it with arrays and things as well, so it's a good one to be aware of. So in principle, the system.out.println method requests the object string representation and prints it. The call to the .string method returning the string representation does not have to be written explicitly, as Java adds it automatically. So what they're saying is that this is the sort of automatic version and this is the explicit version, but because we've got the .toString method in there, we don't need to put it on the end here. Java extends the call at runtime to the following form. So there you go, nice little code shortcut for us. As such, the call system.out.println anti calls the .toString method of the anti object and prints the string returned by it. We can remove the now obsolete printPerson method from the person class. So that one, we can get rid of this. It looks like they're doing some debugging. I'll have a quick watch of it. It's not in English. Just close that. There we go. Right, let's minimize that back down. So if you are uploading that one to GitHub as well, don't forget just to do your commits, your git add, git commit, and then git push. And now we've got the agent programming exercise. The exercise template defines an agent class having the first and last name. A print method is defined for the class that creates the following string representation. Remove the print method and create a public string toString method for it, which returns the string representation shown above. Okay, that's fine, let's do that. So I'm just going to close these down, I don't know why they're open. Let's get rid of them. Let's go to our main class there. Let's create a new class, and this one is going to be called agent. Oh, hang on. Oh, maybe we don't need to. There we go. Okay, so we need to delete this. Actually, we don't need to delete it. What we can do is actually change it to toString. Let's change that to string, and then let's change that to return. Alright, because we've got this system out in here, let's just get rid of that and that curly bracket parentheses. And that should be good. So it says my name is this dot last name, comma, first name, space, last name. Cool, let's give that a run. Let's see what we get back. There we go, we've got all tests passed, so let's submit that. Great, there we go, so that's passed, it's okay that. Okay, let's give that a refresh. There we go, and we've got method parameters next. Actually, do you know what we need to do? GitHub. So git add, git commit -m, completed part 4 exercise 13. And then let's do our git push uorigin and master. There we are. Method parameters. Let's continue with the person class once more. We've decided that we want to calculate people's body mass index. To do this, we write methods for the person to set both height and weight, and also a method to calculate the body mass index. The new and changed parts of a person object are as follows. Right, let's pull up our Apache NetBeans here. So they've changed their constructor, so they've added some extra bits in. So we've got age and name, but they've got height and weight as well. So let's add the variables in. So we can do private int, and we can do weight. Interestingly, we don't actually have to do them all on a new line like they've been doing like that. We can actually take these if we wanted and do them like that, and then they're declared or yeah, declared on one line. So here we can say that this dot weight is equal to 0, and this dot height is equal to 0 as well. So we've got 3 zeros and 1 equal to initial name. Got below that 2 new setter methods, and then the new body mass index method as well. So they're setter methods because they've got the set keyword there. Set isn't actually a keyword, but they've got the set word before it. And remember, we've got these keyboard shortcuts, these code shortcuts. You can actually do getters and setters too. I tend just to type them out. I mean, if I was doing a lot, I'd use the automation there. So set height, and we've got int new height. Then we've got this dot height equals new height. Hang on. Yeah, that's right, isn't it? New height. There we go. So we're saying that the value here, or this value that's being passed, is going to be stored in this variable here on line 14. So that's that one done. Let's create a new one. So we've got public void set weight, and then we're going to do int new weight, and then this dot weight is equal to new weight. There we go. And lastly, we need our body mass index method. So that one's different, isn't it? That's a double. So public double body mass index, and we're going to say that double height per 100 is equal to this dot height divided by 100. Something good to point out as well is that their naming conventions are really good. So here, the double height per 100, that is it's a semantic, it lets us know what it actually means. So it's a really good way to name your variables rather than just doing A, B, C and things like that. So because it's a double, we need a return. So we'll just say this dot weight divided by height per 100 times height per 100. Is that good? That looks good. Excellent. The instance variables height and weight were added to person. Values for these can be set using the set height and set weight methods. Java's standard naming convention is used once again. That is, if the method's only purpose is to set a value to an instance variable, then it's named as set variable name. Value setting methods are often called setters. The new methods are put to use in the following case. So here we've got our objects, and we're using the set method. So we've got set height and set weight, and then again here on Johanna we've got set height and set weight as well. A parameter and instance variable having the same name. In the preceding example, the set height method sets the value of the parameter new height to the instance variable height. And here's our example. The parameter's name could also be the same as the instance variables, so the following would work. So you see here we've got int new height, and then this dot height equals new height. Here we've got int height, and this dot height equals height. So this is this height that's set as the instance variable, and this is the one referring to the parameter here. In this case, height in the method refers specifically to a parameter named height, and this dot height to an instance variable of the same name. For example, the following example would not work as the code does not refer to the instance variable height at all. What the code does, in effect, is set the height variable received as a parameter to the value it already contains. So that this keyword means that we're working with a variable in this class. So what we're saying is that that is going to be equal here as well, which doesn't really do anything. It's not useful for us. So instead we've got this dot height, so this will be setting the one up here on the left, so on my line 15, with the value that's passed to it here. Create a class multiplier that has a constructor and a method which returns the value number passed to it multiplied by the number provided to the constructor. You also need to create an instance variable in this exercise. An example of the class in use is there. Okay, let's minimize that. Let's go to Multiplier here. Let's create our new class. So we know that the class is going to be called Multiplier, firstly because they told us, but also because the constructor is called Multiplier as well. There we go. Constructor, so let's do our constructor. So it's going to be private int number, and then we can do public multiplier int number, and then we can say this dot number, which is the one on line 12, is equal to whatever value is passed when the constructor is called on line 14. There we go. We need a public int multiplier, so public int multiply, which takes int number, and then you need to create an so which returns the value number passed to it multiplied by the number provided in the constructor. So on this one we can do a nice easy return. So we can say this dot number, which will be the one again on line 12, multiplied by number, which is the one that is going to be passed on line 18. An example of it here, so let's see, we've got multiply, that looks good. Okay, let's give that a little run. There we go, that's passed, let's get that sent off. And while that's doing that, let's update our Git. So git add full stop git commit -m. So we completed part 4 exercise 14, and then do a git push u origin master. There we go. So let's close that. Give that a refresh. Okay. The object may also call its methods. For example, if we wanted the string representation returned by toString to also tell of a person's body mass index, the object's own body mass index method should be called in toString method. So this is what we've seen before, very familiar with this. And then at the end here we've got the this dot to body mass index. So when an object calls an internal method, the name of the method and this prefix suffice. An alternative way is to call the object's own method from the body mass index method, whereby no emphasis is placed on the fact that the object's own body mass index method is being called. So here we go again. So this example, we've got the this there, and then on this one that we don't. So statistics. So this is a nice 4-parter. Oh, and we've got a 6-parter as well. That should be good. Oh, we've only got 2 left. Gosh, we're whizzing through this. Right. Create a class statistics that has the following functionality. The file for the class is provided in the exercises template. Right, let's get this one open then. So this is statistics. So we've got statistics there, and we've got, whoops, and we've got the main program file here. You can write test code here, however, remove all unnecessary code when doing the final parts of the exercise. The objects must be created in the correct order in the main program. Okay, so that's good to know. First, the object that tracks the total sum. Secondly, okay, cool. Right, so we've got the statistics. A method add number adds a new number to the statistics. A method get count tells the number of added numbers. A class does not need to store the added numbers anywhere. It is enough for it to remember their count. At this stage, the add number method can even neglect the numbers being added to the statistics, since the only thing being stored is the count of the numbers added. The method's body is the following. So private int count, public statistics, initialize the variable number count here, write code here, write the code there. Right, okay, well let's get that written in, and then see where we go next. So we need private int count, we need public statistics, which is going to be our constructor. we need public void add number, and that's int number. Then we need public int get count, like that. So public int get count is going to be return this dot count. Let's see. Class does not need to store at this stage the add number method. Can even neglect the numbers being added to the statistics since only these count the number added. Just have a little look further down and see if we have any more info. The following program introduces the class's use. So we've got statistics equals new statistics. 1, 2, 3, 4. Okay, so I guess each time that happens we need to do like a count plus plus or something. Oh, this dot count plus plus. Can we do that? Okay. Oh, that's in the wrong thing, isn't it? That's in the add number and it needs to be in statistics like that. Okay, let's go back to our main here. And it says for it to work they need to be called in order. So correct order in the main program. First the object that tracks the total sum. Okay, well let's do the example they've got here. So statistics stats equals new statistics, like that, and then let's statistics, and then I'm going to copy that so I don't have to keep typing it out. We're going to do add number, and then we'll do 3, and then if we press Control Shift and up, it duplicates the lines. So we can do 3, 5, 1, and 2. And then if we system out statistics dot get count, let's see what we get back when we run that. So it's still running. Oh, it's 1. We get 1. Okay. Oh, hang on. So here we're calling the add number method, but I've put the plus plus in the constructor. So let's put that there. Let's give that a run now. 4, excellent. So we've got the 4. Expand the class with the following functionality. The sum method tells the sum of the numbers added. The sum of an empty number statistics object is 0. The average method tells the average of the numbers added. The average of an empty number statistics object is 0. Okay, right, let's go back to statistics. So we've got private int sum. So we've got add number, we've done that. Get count, we've got that one. So here, this is the end of the class, so don't write past that point. We've got public int sum, and we've got, just put a return in, just a blank sort of one, and then public double average, and then return, it's going to be a double, so we'll just leave that for that right now. So the sum method tells the sum of the numbers added. The sum of an empty number object is 0. So if we are updating the sum of the numbers added, let's think if we can update our add number. So let's just do this dot count, and then we can do this dot sum plus equals the value passed to it from here. The sum method tells the sum of the numbers added. That's fine. So if it's just the sum, all it needs to do is return sum. Okay, and then the average method tells the average of the numbers added. The average of an empty number is 0. Okay, So let's have a think. So if this dot sum does not equal 0 and this dot count does not equal 0, then return return equals 1.0 times this dot sum divided by this dot count. Otherwise, why is it not like that? Let's have a look. There we go. Otherwise, we will return, I guess, 0. Let's give that a run and see what we get back. So we should get some green and red. Oh, we've got quite a lot of green. Oh, okay, so that looks good. So that one's talking about user inputs, and we haven't got to that stage, so all of this must be working so far. So if we give that a refresh, we should have... No, it doesn't give us any points. Oh, okay, fair enough. I thought it might give us 2 points or something to show that we completed a part of it. Okay, so part 3, sum of user input. Write a program that asks the user for a number until the user enters -1. The program will then provide the sum of the numbers. The program should use a statistics object to calculate the sum. Do not modify the statistics class in this part. Instead, implement the program for calculating the sum by making use of it. On the program. So enter numbers 4, 2, 5, 4, -1 is 15. Okay. Okay, so do not modify the statistics part. So we're going to have to head back to the main. So let's head over here. Oh, I've accidentally clicked history here, that's why it looks a bit odd. So if we just click source, that will get rid of that. Okay, so let's get rid of these for now, because we don't really need those. We just had those for testing, didn't we? So let's get a prompt. So enter numbers, and then write a program that asks the user for a number until the user enters -1. Right, so let's do while true, and then, oops. So while true that, we need somewhere to store the user input. So int input is equal to scanner.nextInt. Remember, you can do the integer dot value of scanner.nextInt if you wanted instead. And then we can say if input is equal to -1, right, I'll leave that there for now. And then once it's provided the sum of the numbers, it'll need to break out of that. So if we're just doing a sum of numbers, we can just say sum, and then that is going to be plus equals, so it's going to be an object name, and then the sum method. So let's quickly create an object. So statistics equals new statistics. There we are, and then this will be equal to the object, which is statistics dot sum. Okay. Let's just double check this again. So write a program that asks the user for input. We've got that. Until they enter -1, we've got that, and that will loop round. The program should use a statistics object to calculate the sum. We've got that. Do not modify the statistics class in this part. Instead, implement the program for calculating the sum by making use of it. Okay, so we've got that. Let's test it locally and just see if we've got any. I think last time we had 79% pass. So let's see what we've got this time. Oh, still 79, that's fine. So let's have a look at this. Change the previous program so that it also calculates the sum of even and odd numbers. Define 3 statistics objects in the program. Use the first to calculate the sum of all numbers, the second to calculate the sum of even numbers, and the third to calculate the sum of odd. Okay, so let's rename this. So I'm going to press Ctrl R on my keyboard and call this one sum. Then we're going to create 2 more, so I'm going to press Ctrl Shift and up, and we're going to call this one even, and we're going to call this one odd. So that's the first bit sorted. And change the previous program so it calculates the sum of odd and even numbers. So thinking about this one, we've got these 3 objects and we've got an if statement. We can use the even and odd objects in the if statement to update our sum. So if we do else, and then inside the else we can put another if, sum dot add number then we can say that if user if input mod2 equals 0, that means it's going to be even. So in that event, or that option, we can use the even object to add a number equal to the input. Else, so if it's not odd, sorry, if it's not even, it must be odd, which means that we can then do odd dot add number also equal to input. So end of odd even. If end of while. Right, so we've got those. So this will keep looping round. So if we enter 4, it will loop round, drop out here, then it will loop round again because we haven't entered -1. In fact, what I'm going to do is run it locally, and I'm going to enter this and see what we get. I guess we still need to do these 2 bits. So the sums. So 4, 2, 5, 2 and -1, sum of 13. So that first bit's working, so we just need to do the sum of even numbers and the sum of odd numbers. So what we can do is Control Shift up, and then sum of even numbers is going to be plus even. Sum of odd numbers is going to be odd. Okay, let's give that a run and see what we get back. That was a really good challenge. That was quite a good one to get your head around. I quite enjoyed that. Oh, we did it as well. That's great. Let's send that off. So let's update our GitHub. So git add full stop, git commit completed part 4 challenge 15. If you ever forget to put the double quote on the end here, you get this closed diamond brace. If you just put a closed quote on, it will sort it out for you. So that's quite good. And then we'll do git push view origin and master. That's great. Get rid of that. Click on here. Let's close that down. There we go. Just give that a refresh just to make sure that we did receive all of the points for this one. Cool. Right. So this is it. This is the last one of the first part of part 4. So let's open this. So at the University of Helsinki student canteen, UNICAF, students pay for their lunch using a payment card. The final payment card will look like the following as a class diagram. Okay, so we're going to need to create that. So let's right click here and let's start creating stuff. So we need payment card. So here we've got the minuses. So in this middle section we've got minus, which means it's private. It's in this middle section, so that means it's an instance variable. And then all of these are public. What have we got? Constructor, and then different methods that do different things. So add money to string, things like that. So I'm going to get rid of this, and let's do private double balance. Then we're going to have the constructor, so it's going to be public payment card, and that takes a double, so let's do double amount. We can look at changing that if we need to. So I guess that's going to be to update the balance, so that this dot balance equals balance. Let's change that to balance. Then we've got payment card double, eat affordably. Okay, so we've got the eat affordably. So public void eat affordably. Then we've got eat heartily, so public void eat heartily. Then we've got add money, so that's a double. Add money. Hang on, it says it's a void. There we go. So change that to void. Add money is going to be double amount. So that's going to be the amount that we're going to add. And then we've got the toString method at the bottom here. So if we do alt insert toString, we can just do that. No, I'm sure we'll need to change it later. Okay, in this exercise series, a class called payment card is created, which aims to mimic Unicaf's payment process. The exercise template comes with a code file called main, which contains the main method. Add a new class to the project called payment card, which we've got. Here's how to add a new class. We are happy with that, hopefully. So first create the payment card object's constructor, which is past the opening balance of the card. So they've called theirs opening balance. So let's change that, opening balance, makes sense I suppose. And which then stores the balance in the object's internal variable. Then write the toString method, which will return the card's balance in the form the card has a balance of X euros. Okay, so let's change this. So it's going to say, where was it? The card has a balance of space this dot balance plus and then euros. There we go. So we've done the payment card, we've done that. The main program tests the class. Okay, so let's go back here. And then we can do payment card equals new payment card. And then we're going to pass it some euros. And then if we system out print card, we should get 50 like they've got just there on the right. Oh, €0, that's not good, is it? Oh, I updated the name here, but I didn't update the name there. So opening balance, there we go. Let's give that a run. There we go, perfect. So, making transactions. Complete the payment card class with the following methods. So we've got eat affordably, which we've done, eat heartily. The method eat affordably should reduce the card's balance by €2.60 and the method eat heartily should reduce the card's balance by €4.60. Okay. So let's go here. So eat affordably. So we can do this dot balance minus equals 260. And then here for eat heartily we can do this dot balance minus equals 460. And then we've got some test cases, some tests here. So we've done that. So let's do card dot eat affordably, and then system out the card again, and then eat heartily. Eat affordably, and then finally a system out again. Okay, let's give that a run. So we should have 50, 47, 40, and then 40 point. Perfect, excellent. This is quite a nice tutorial to follow along. So what happens if the card runs out of money? It doesn't make sense in this case for the balance to turn negative. Change the methods eat affordably and eat heartily so that you don't reduce the balance before it turns negative. The following main program tests the class. Okay, right, so we can add an if in, can't we? So we can say if this dot balance is greater than or equal to 260, we can do this. And if it doesn't, which it doesn't say for us to print out a method yet, or sorry, it doesn't tell us to print out a message yet saying there's no funds. So we won't do that now, but maybe they will in a minute. So we've got this dot balance, so it's going to be the same as the one above, greater than or equal to 460. And then there we go. Cool. Right, so let's head back here. So we've got to card eat heartily, so that's a heartily now. Oh, they're both heartilies. And then we need one of those to separate it. There we go. So let's give that a run. So then we should get, oh, I didn't change it, did I? So here we've got 5. Let's run that again. Great, that's exactly what they've got here. So this is all going well so far. The second call to the method eat heartily above did not affect the balance, since the balance would have otherwise become negative. Add the following method to the payment card class. So we've got add money, double amount. The purpose of the method is to increase the card's balance by the amount of money given as a parameter. However, the card's balance may not exceed €150. As such, if the amount to be topped up exceeds the limit, the balance should in any case become exactly €150. What we can do is say if amount is greater than 0, this dot balance plus equals amount. Let me think. The purpose of the method is increased by that amount. However, the card's balance may not exceed. As such, if the amount to be topped up exceeds the limit. Right. So what we can say is if this dot balance plus amount greater than 150, this dot balance equals 150, and then maybe else this dot balance plus equals amount. Let's try that. So let's head back to our main. So we've got card payment of 10. we have got card add money 15, and then we've got a system out. Then we've got add 10 and then add 200. Okay, so let's pinch this. So let's add 10 to this one, and then 200 to this one. Delete that, give it a run. Keep everything crossed. So we've got 10, 25, 35, and 150. That's looking good. Ooh, we've got more. So change the add money method further so that if there's an attempt to top it up with a negative amount, the value on the card will not change. Ah, okay, let's head back here. So if it needs to be a positive value, so we could say if amount is greater than 0, this dot balance plus equals amount. So we probably won't need that one now. Let's go back here and try that. So we've got negative 15 on there. So let's just do negative 10 because we don't need to keep changing it, do we? So then here's the 10 plus the 15. The negative 10 didn't work and the 200 still stops it. So this is the last bit. Write code in the main method that contains the following sequence of events. Okay. So we need to create a card for Paul, and that has an opening balance of 20. We need to create one for Matt with an opening balance of 30. Paul eats heartily, so Paul dot eat heartily. Matt eats affordably, so Matt dot eat affordably. The card's values are printed, each on its own line, with the card holder name at the beginning of it. Let's do a system out. Paul. And then, so here they put Paul's card and Matt's card like that, so I best change these. So I'll just double click it, press Ctrl R, and then what are we changing it to? Paul's card. That's good, and then do the same for Matt as well here. So Ctrl R, Matt's card. There we go. So that's going to be plus Paul's card. We can copy that for Matt's card. So Matt's card. Oh, mine's got red on it because I've got a typo here. So that should be a capital C. There we go. There we are. Right. Let's see what next. What is next? The card's values are printed. Paul tops up by 20 euros. So we can do Paul's card dot add money 20. Matt eats heartily again. Gosh, Matt's going for it. So Matt's card dot eat heartily. The card values are printed, each on its own line with the card holder name. Let's copy that. What next? Paul eats affordably. Paul eats affordably. So Paul's card dot eat affordably twice, so Control Shift and up on the keyboard gives us 2 printouts of that. Matt tops up 50 euros. So Matt card dot add, is it add money? Is it add funds? Add money, there it is. Add money, and then we're adding 50 to it. And then the card's values are printed again, right? Let's just do that, put those in there. Whew. Right, let's give that a run. Run against the local tests and see what we get back. Fantastic, excellent. Let's get those sent off. You probably noticed that some of the figures have rounding errors. In the previous exercise, for example, Pekka's balance of 30.7 may be printed as 30.7 with lots of zeros and a 3. This is because floating point numbers such as double are actually stored in binary form, that is, in zeros and ones using only a limited number of numbers. As the number of the floating point numbers is infinite, in case you're wondering how infinite, think of how many floating point or decimal values fit between the numbers 5 and 6, for instance. All of the floating point numbers simply can't be represented by a finite number of zeros and ones. Thus, the computer must place a limit on the accuracy of stored numbers. Normally, account balances, for instance, are saved as integers, such that, say, the value 1 represents 1 cent. Wow, look at that, guys. We are all completed and up to date on this one. So the next section is going to be objects in a list. So with that, I will leave you to it for this evening, and I will start recording the next section. But as always, good luck and happy coding.